Hey everyone, Linus here. Today we're diving into the world of computer memory. Just like our brains store information, computers need a place to keep their data. Memory is what makes it all possible. Without it, your computer would be as useful as a potato. Imagine trying to play a game or edit a video without memory. Your computer wouldn't be able to store the game's progress or the changes you made. It'd be like starting from scratch every single time. Memory is essential for everything your computer does, from browsing the web to running complex software. It's the unsung hero that makes your digital life possible. So what exactly is computer memory? In simple terms, it's the storage component of your computer. Think of it like a giant filing cabinet where all your data is stored. This data can be anything from the operating system that boots up your computer to the photos and videos you take on vacation. Whenever you open a program, edit a document, or stream a movie, the computer accesses the necessary data from its memory. There are different types of memory, each with its own strengths and weaknesses. Understanding the differences between them will help you make sense of how your computer works. Computer memory can be broadly categorized into two main types: primary memory and secondary memory. These two types of memory serve different purposes and are essential for the computer's performance. You can think of these as your computer's short-term and long-term memory. Just like our brains, computers need both types to function efficiently. Primary memory, also known as volatile memory, is super fast and directly accessible by the CPU. This type of memory is crucial for the computer's immediate tasks. It's used to store data that the computer needs to access quickly, like the programs you're currently running. This allows for smooth multitasking and quick data retrieval. However, it's temporary storage, meaning that its contents are lost when the computer is powered off. This is why saving your work frequently is important. Secondary memory, on the other hand, is non-volatile memory. This type of memory is essential for long-term data storage. This means it retains its data even when the computer is turned off. It's where all your important files and data are kept safe. Think of it as your computer's hard drive, where you store all your files, applications, and the operating system itself. Without secondary memory, your computer wouldn't be able to retain any information after being powered down. Let's talk about RAM, which stands for Random Access Memory. This is your computer's main workspace, like the desk in your office. It's where your computer stores data it's actively using. When you open a program, your computer loads it from the hard drive into RAM. This allows the CPU to access the program's data much faster, which is why more RAM generally means a faster and more responsive computer. The more RAM you have, the more programs and data your computer can handle simultaneously without slowing down. Think of it like having a bigger desk. You can work on more things at once without things getting too cluttered. Section 5. Primary Memory, ROM, the rulebook. Now, let's talk about ROM, or read-only memory. Unlike RAM, ROM is non-volatile, meaning it retains its data even when the power is off. Think of it like the rulebook your computer uses to boot up. ROM contains the instructions your computer needs to start up, called the BIOS or UEFI. These instructions tell the computer how to find and load the operating system from your hard drive. ROM is also used in some other devices, like your graphics card and your smartphone, to store firmware, which are permanent instructions that control how those devices operate. Section 6. RAM versus ROM, a quick comparison. So what's the difference between RAM and ROM? Here's a quick breakdown. RAM is like your computer's short-term memory, while ROM is its long-term memory. RAM is volatile, meaning it loses its data when the power is off, while ROM is non-volatile, RAM provides the workspace for your computer to run programs and store data temporarily, while ROM provides the essential instructions for your computer to boot up and function correctly. Section 7. Secondary memory. Your computer's hard drive. Secondary memory is your computer's long-term storage, where you store all your files, applications, and the operating system itself. Unlike RAM, secondary memory is non-volatile, so it retains data even when the power is off. The most common types of secondary storage are hard disk drives, or HDDs, and solid-state drives, or SSDs. HDDs are cheaper and offer more storage capacity, while SSDs are much faster, but also more expensive per gigabyte. Other examples of secondary storage include USB flash drives, SD cards, and external hard drives. These devices allow you to store and transfer data between different devices. Section 8. Bytes explained. From bits to yottabytes. Now, let's dive into the fascinating world of how we measure storage capacity in the digital realm. The basic unit of information in computing is a bit, which can be either a 0 or a 1. This binary system forms the foundation of all digital data. 8 bits make up a byte, which is the most common unit used to measure file sizes. Bytes are the building blocks for larger units of data. Here's a quick rundown of the most common storage units. Byte 8 bits. Kilobyte. 1024 bytes. Kilobytes are often used to measure small files, like text documents. Megabyte 1024 kilobytes. Megabytes are commonly used for medium-sized files, such as images and MP3s. Gigabyte. 1024 megabytes. Gigabytes are used to measure larger files, like videos and software applications. Terabyte. 1024 gigabytes. Terabytes are often used for large storage systems, like hard drives. Petabyte. 1024 terabytes. Petabytes are used in data centers and for big data analytics. Exabyte. 1024 petabytes. Exabytes are used to measure massive data sets, often in scientific research. Zettabyte. 1024 exabytes. Zettabytes are used to quantify the vast amounts of data generated globally. Yottabyte. 1024 zettabytes. Yottabytes represent the largest unit of data storage, used for theoretical and futuristic data needs. As you can see, each unit is 1024 times larger than the previous one, creating a hierarchical structure of data measurement. So, a terabyte is 1024 times larger than a gigabyte, and this pattern continues up the scale, illustrating the exponential growth of data capacity. Section 9. Memory in action. Real-world examples. Let's look at some real-world examples of how memory is used in computing. Memory plays a crucial role in the performance and functionality of various computer tasks. Playing a game. When you play a game, the game's files are loaded from your hard drive, which is secondary storage, into RAM, which is primary storage. This process is essential for the game to run efficiently. The CPU then accesses the game's data from RAM, which allows it to run smoothly. Without this transfer, the game would be slow and unresponsive. Editing a document. When you edit a document, the document is loaded from your hard drive into RAM. This enables quick access and real-time editing. As you make changes, they are saved in RAM. This temporary storage allows for quick modifications and ensures that your work is not lost. When you save the document, the changes are written back to the hard drive. This process ensures that your edits are permanently stored and can be accessed later. Browsing the web. When you browse the web, Your browser stores website data, such as images and cookies, in RAM. This temporary storage helps in speeding up your browsing experience. This allows websites to load faster when you visit them again. By storing frequently accessed data in RAM, your computer can quickly retrieve it, making your online experience smoother and more efficient. Section 10. Conclusion. The memory hierarchy. Understanding the different types of computer memory and how they work together is crucial for anyone who uses a computer. From the lightning-fast RAM that powers your applications to the massive hard drives that store your files, each type of memory plays a vital role in making your digital life possible. As technology continues to evolve, we can expect to see even faster and more efficient memory technologies emerge. The lines between primary and secondary storage and enabling even more powerful and responsive computing experiences. So, the next time you boot up your computer, take a moment to appreciate the incredible power of memory at work.